An ancient nuclear reactor that was churning away 2 billion years ago sounds like a myth. Maybe it's because the term reactor usually implies a man-made structure, but in this case, the reactor is a region of natural uranium within the Earth's crust, found in Okla, Gabon. When we think about nuclear reactors, we think of the ones created by humans. They're designed and manufactured specifically to slow the process of nuclear fission, producing energy as an alternative to coal power. But surprisingly, nuclear reactors aren't solely human-made. So far, only one naturally occurring nuclear reactor has ever been discovered. This natural reactor has puzzled scientists and appears to have been created under a unique set of circumstances unlikely to be replicated anywhere else on Earth. But where did this nuclear reactor come from? And how does it work? If you want to learn everything about the nuclear reactor, then make sure to keep on watching. The reactor was discovered in 1972, when a group of French scientists tested uranium ore from a mine in Gabon. Uranium ore is typically composed of 3 varieties of uranium, each with a different number of neutrons. Uranium-238, the most abundant, uranium-234, the rarest, and uranium-235, which nuclear scientists are most interested in due to its ability to sustain nuclear chain reactions. When the French scientists began to examine the uranium samples mined in Gabon, they expected to find around 0.72% of uranium-235 in the ore. This percentage is the same found in other samples collected from places around the globe, as well as from the Earth's moon and from studied pieces of meteorite. Instead, the sample contains 0.17% of uranium-235. For many, this 0.003% discrepancy would seem insignificant. But as Scientific American explained, this was hardly the case. It's a total of 440 pounds of missing uranium-235 from the Gabon mine. It hadn't been lost or stolen. Instead, this missing 0.003% had undergone nuclear fission and split into other atoms. This conclusion may very well have furrowed some brows, since there are 3 very specific conditions that a reactor needs to churn out energy continuously. And as even scientists had struggled to create a nuclear reactor, it seemed unlikely that nature just happened to create one purely by accident, but not impossible, because that is exactly what happened. The conditions that the natural reactor happened to fulfill are as follows. The first was obtaining a meaningful amount of uranium-235 to fuel the reaction. While 0.720% may appear to be a small percentage, it is ideal for nuclear fission, and when our samples from Gabon are compared to other samples from around the world, it is likely that this was the percentage over 2 billion years ago when the reactor began. The second condition is a neutron source. Uranium-235 naturally decays into thorium, releasing a neutron in the process. This neutron can then speed up and collide with another uranium-235 atom, initiating the fission process. Nuclear fission occurs when an atom splits into smaller atoms, releasing energy in the process. This neutron fuses with a uranium-235, and the two combine to form the unstable uranium-236. The uranium-236 is then overwhelmed by instability and splits, producing a variety of smaller, more stable atoms as well as some neutrons. These neutrons can then happily shoot towards other atoms, causing the chain reaction to continue. Sadly, all good days are numbered, even for a happy natural reactor. The levels of uranium-235 got used up and the level was too low to sustain any more meaningful reactions. The reactor eventually slowed to a stop, leaving only a few traces behind that it ever existed, including the enigma of the missing uranium. Perhaps natural nuclear reactors existed in several other places on Earth 2 billion years ago, and we have yet to discover evidence of them. However, natural nuclear reactors are still unique and, in many ways, irreplaceable, because the Gabon reactors were so stable, ran for so long, and have been preserved for 2 billion years. Scientific research on these unique natural reactors provides important insights into anthropogenic nuclear power and nuclear waste storage. But one thing is for sure, Mother Nature appears to understand how to run a nuclear reactor. If you watched all the way to the end, then don't forget to like and subscribe for more tech videos.